Currently in manufacturing, there are a few different kinds of robots that are circulating. There are cobots that are made to work collaboratively with people, so they are called cobots, and then there are manufacturing arms similar to these ones that are used in cells to work not with human but to automate some sort of the process. The cells are specialized. Currently we can see in the world a lot of pick and place robots that are used just to pick from one conveyor and place to another, or to pick from the conveyor and place what we need in the some sort of the machining. Hence the first robots came to us not long ago. It is said that the first robots came with manufacturing 3.0, and we calculated that manufacturing 3.0 started in 1970s with a huge wave of automation. It started in really key places, so it started in automotive, electronics, pharmacy, in these kind of sectors. Hence, the bigger and wider need for automation raised the need to change the human, because the human couldn't reach the needed and wanted speeds as the machine can get. So firstly, we see the huge key requirements that are risen for robots in automotive. Germany is a big player there for robotization in the whole world, and they were one of the key players to raise the need for robots. Currently, we can see that Singapore is the leading today country. For example, for 100,000 of people, they have around 920 robots. Currently, Germany, for example, has 100,000 people. In country, around 270 robots. Here in Lithuania, we calculated that for 100,000 people, we have only 5 robots. So here in Lithuania, we have a big steps forward to make a better, wider use for robots, and I hope you will see a lot of them during our tour. Here in this factory, we have in total 4 different kinds of robot cells that are used in many different ways. So the first one, which is finalized and is being used for more over than 1.5 years, is our so-called Robocut. So Robocut does the plotting. It has a lot of different parts in it. It mainly has pick and place part, where he picks the sheet of cotton paper and places it on its working area. Then it has a cutting wheel it has to make folding lines, and as well it has a printer that prints out the code that helps in other processes operator to understand where the part should go. So this plotter provides us with a packing solution. So it develops packages for furniture factories, so-called. So we have a big variety of different kind of packages that we need to cut out. And at first there were 3.5 person working on this job. So they were cutting and preparing packages for furniture to be packed, and now we have only half of the person who's constantly working on the solution, just supporting robot, providing the orders and etc. This robot is connected to the cloud, so all the orders that you need for packaging to be cut can be placed anywhere in the office. Then they are sent to cloud, and the robot just grabs all the data from the cloud and does all the work fully. We minimize the need of people from 3.5 to only half the person. The work is hugely done via robot, and it can work 24/7. So that's a good step up. But what he only needs is that the sheets of paper would be put in the place where he picks it up, and the pallet where he stores all the done orders. We leave it even for the night, and he works for us even 24/7. But if you leave the robot for itself, sometimes there's life. You can have some sort of the errors and etc. We have here the communication via messenger. So the robot sends the information if it has stops or some kind of error occurred during the work via messenger to the operator. An operator can hastily come back and look what has happened and how to fix everything. So this is the first robot. The second robot is our robot Carpenter that we are finalizing now. This is really cool robot that can take out the persons out of the working. So you can change the need for the carpenter who is working near milling with a big heavy wood piece, and if you imagine the machine itself, it can hurt people, and usually you could see the carpenters with few less fingers. So the people which want to work near such kind of machines are minimizing, and we saw this and we've developed this too. So basically this robot, what he does, he has a conveyor where all the wooden pre-parts are placed, and what the robot does, he picks up the part and goes to every different tool and does the work that he needs. So for example, he does the surface milling, then he does the surface sanding. If it needs some holes, he goes to the drilling post and drills different kind of holes. We have even capability to have even more posts that has some sort of the cutting to cut out the parts that you need. The small mill where you have really small mill element and etc. So the capability is full. We have a big tool changer as well, because going from part to part to part, there may be some sort of the need to have a different gripper, which would grip tools kind of differently. So we have one which has like a finger hole, so the robot drills out the hole in which the fingers comes out, and we can pick the item and go to the different post. Then there is a gripper which takes the item from the side. Then there is a gripper which takes from front. So depending on how you need to develop and work on different places, so different grippers are then used. How you program the robot. So what we have done, we have everywhere we have the PC. The PC talks with the robot and provides all the necessary data, how you need to work on the robot and how you need to develop it. So to think about it, we have a CAD/CAM system which develops all the paths needed to go through the robot. The paths are generated dependently on which kind of tool the robot needs to do the work, and then the PC program combines all of the data and pushes it into the robot, and then we have the fully automated part there. So just for you to think about it. And as well, we have there the information. So there we have a lot of different moving parts. Something can clog on, etc. We can have a lot of unneeded waste there, etc. So there is as well an information tool. That operator gets information out of the robot via messenger and can go out and look what has happened and have a maintenance there. The third robot that is currently working, yes, so it's sanding robot. We have two parts of the sanding. One part is we have a camera that looks from up down to the plane. It's used mainly for the table sanding, so you place the table and we start to do the sanding. So the camera grabs the photo and then calculates all the necessary paths to go through, and then the robots go through it with its sanding machine and machines everything, so you would have a smooth table. The second part is our 3D sanding. So there would be a pre-assembled furniture, for example, and you would need to work on different sides of the furniture. So we have there as well CAD/CAM system that generates the paths, and then you load everything into the PC, and PC combines all the necessary planes, and then the robot works on it and machines everything out. So you would have nice and cleanly sanded part. We are currently constantly working on this solution, and we see that everything is moving forward quite hastily there. We are currently doing a lot of work as well. What's interesting there, so we have there a modular tools that suck on the rotational table. Then we can place any sort of the furniture, so table, bedside, or any kind of big furniture there. Then we set the robot, you can suck it on, so it sucks on, and you have quite heavily sucked on element that you can do all of the sanding. And just imagine when you suck on and the robot goes in, it has a lot of the force there, and while it machines, you need to think about a lot of machining moving forward and producing quite good parts. And the fourth one that we are really proud of it, and it really branched out into the two products now. At first it was one product, so it is Robo Paint, we call it, and easy to teach solution. So basically what we have there two kinds of the painting. So one kind is as well, we have the camera snaps the pictures, sees the plane, and then it paints on the surfaces that we want. And second is we have easy to teach solutions. So we have the tool that the normal painter uses to paint on the furniture. We place on our 3D tracking system, similar to what we have here as well, and it tracks what person is doing. So it tracks the person's movement. Then we have a lot of different high-end filtering there that filters out and leaves only needed paths there, and we have the same movements with the same velocity for the robots. The key component there is everywhere we can see that we are struggling with the process, so we need to have the very same movements as the person is having, because we could spread the paint the same way that person is spreading. Then the pre-processed paths are placed into the robot, and we have those paths. Moving forward there as well, we have AI-based tool there, which is kind of interesting. We have from the very same camera, we grab the image of what kind of the part has came in on the conveyor belt to our working area, and from then the AI takes out what kind of product it is and automatically loads everything into the robot. So we have mix and match of AI there, so it's kind of cool to look how what you need to do is to just place on conveyor belt different parts, and then the robot itself decides whether this is a table or bedside table or something even wackier or different. For example, maybe a chair. I have said, we have the easy-to-teach solution now. It's kind of heavily under development, the tracking system that can gather all the movement data and then pre-process and provide it to the robot. We see it as a big solution because currently robot manufacturers, they are not really looking at it as a new solution for the robot. They are mainly keen on just to provide the robots, and the other integrator companies would pick it up and integrate in any different way. And just to think about it, we've talked with a lot of different companies, and it would take for one hard-to-do part to teach the robot from 1 to 3 months, just to have all the parts needed to go through the robot, etc., to gather everything. And what we've tried to do the very same processes as well, and we've managed to speed up even 5 times the time which is needed to teach the robot to go via very same paths, etc. So we are really moving forward, and we are really keen on to develop strong and good tool there, and we can see it. We can move to any other different kind of robotic process. For maybe it could be some sort of even sanding, maybe it could be as we are currently using painting. It could be soldering maybe, or anything you think about. So there is the hands opened, and hopefully you see it as well as one of the really interesting parts. This company, what we are something between integrators, and we are something between the niche that is not yet fulfilled for digitalization methods, where we can see that big companies such as IKEA are using a lot of automation, robots, etc. But smaller companies, SMEs, they are not keen on into stepping in this new wave of manufacturing 4.0 and digitalization, because there aren't any tools that would be developed and prepared for them to work on. So it's sad. We see that. We are coming here to do this, to help them, to provide them robots that could be used for small batches, and to help them to step up and go into that all-wanted manufacturing 4.0.